we have two more of these logarithmic equations to do. And these are not loop-de-loop problems because they have logarithms on both sides. And remember, your loop-de-loop problems, like you had on your quiz, have logarithms on only one side, right? So what do we do when we have them on both sides? Well, first of all, we can't have this. So we're going to put these two together. When you put them together, and again, I'm only looking on the left side here where there are two. When I put these together, I'm going to have one logarithm of something. The something will either be a times or a divide. Which is it in this case? Divide. So inside this parenthesis, so it's log base 7, inside this parenthesis is going to be 2x over 3. Because when I put a subtraction together, it goes together as a division. All right, everybody good? Now, yesterday, we looked at one problem that was like this, that had logarithms on both sides. Anybody remember what we did? Giovanni?
You just set 2x over 3 equal to 5.
Exactly. Basically, we can get rid of those, and we have 2x over 3 equals 5. Now, I'm going to tell you right now, a huge mistake that's made, a very common mistake that's made is kids go back to the original problem, and they just cross them all off. No, you can't do that. You can't cross the logarithms out or drop the logs, however you want to refer to it, until you have 1 log equals 1 log. Then you can drop them out, okay? So you've got to put them together first. Now, basic equation now is solved, so 2x equals 15 and x equals 15 over 2. Is that okay? Now, when I look at the next one, isn't it very, very similar? So these two have to be put together. So my log base 13 is something equal to the log base 13 of 12. So these two are going together. Whatever I put in here is either going to be a times or a divide. What is it in this case?
3.
It's another divide. So in here is going to go 3 divided by x. It's always first divided by second. Now, can I drop the logs at this point? Yep. So 3 over x equals 12. How do you solve that? Well, I don't times by 3. I times by x. I want to move my denominator. So 3 equals 12x. And then I will divide by 12. So x equals 3/12, which reduces to 4. So basically there's two kinds of logarithmic equations. There's the kind that have logs on one side, we loop-de-loop. There's the kind that have logs on both sides, we drop the logs. But no matter which kind it is, if you have two on the same side, you have to put them together first. Before you do anything else, you have to put your logarithms together. And they always go together as either a divide or a times, depending on that right there. Are we good? Okay. All right, so that's it for 3-5. Now, we're going to spend some time with some word problems. Okay? I need you in your notes, up at the top here, I need you to write down 2 formulas. we're gonna use these two formulas to do all of our problems. So we'll talk about what the formulas, what all the letters mean, and what we do with them. But first, I want you to write them down. So we have what's called the Pert Formula. So that's A equals P times E to the RT formula, or RT power. It's called the Pert Formula, for obvious reasons. And then we have A equals P, 1 plus R over N to the NT. Every problem we do, and if you look, we got a couple pages of word problems here. Every problem we do is going to use one of these two formulas. I'm going to start by explaining this one. This formula is only used in money problems. So in other words, we're going to be talking about saving money for the future. Okay? Only use this formula in a money problem. So if you look, some of your problems involve colonies of microorganisms growing and half-life of elements. Not this one. This one is only for money. A stands for the amount that you end with. So it's the ending amount. P is the starting amount. That is a 1. It's not a letter, it's the number 1. This is a money problem. And guess what R stands for? The interest rate. So R is the interest rate. And always put it in as a decimal. So in other words, if the interest rate is 6%, you would put that in as 0.06. Always goes in as a decimal. Now N is the tricky one. There's two N's and they mean the same thing. They stand for the same thing. N is the number of times per year that you compound your interest. How many of you have a savings account? You better all have a savings account. And you get interest on that savings account. Interest is money the bank gives you, right? They get to keep your money, so they pay you a little bit for it. Your interest is probably compounded monthly. So that means, if it's compounded monthly, that means N would be 12. 12 times a year. If it's compounded weekly, then N would be 52. Daily would be 365. Yearly would be 1. This is the compound interest formula used for money, and N is how many times a year we compound the interest. And then T is the number of years. Okay? You need to know what each of those letters stands for. All right? I will probably, if you keep me happy, give you the formulas. Although we'll do so many, you'll probably memorize them. But I'm not going to tell you what the letters stand for. You need to know. Okay, so I got it all outlined up here. So let's see how this works. We'll talk about this one in a minute. But let's look at problem number 1. Problem number 1 on page 30. how long will it take for an investment of $1,000 to double if the bank pays 2.5% interest compounded quarterly? Now, that compounded quarterly tells me this is my formula, because this formula talks about compounding a certain number of times a year. What does quarterly mean? 4 times a year. So N is gonna be 4. All right, so here we go. Tell me, do I know my ending amount? Oh, wait, I think I do.
$2,000.
$2,000, because aren't I trying to double my investment? So my ending amount is 2,000. Do I know my starting amount? 1,000. That's a 1. Don't put anything in. That's a 1. What's the interest rate? Do I know it?
2.5.
Okay, but I don't put 2.5. What's 2.5%? 0.025. It's gotta go in as a decimal, guys, not as a percentage. 0.025. We said N was 4, right? And the other N is also 4. They're always the same thing. Do I know T? That's what I'm looking for, isn't it? Doesn't the question say how long does it take? So I'm gonna solve this horrible looking equation, and I'm gonna know how long it takes me to double my money. Okay, so you tell me, obviously, calculator active here. You tell me what you'd like to do first in terms of trying to solve this equation. Divide by 1,000? Great idea. We can't have this number here. We talked about that the other day. We're gonna divide by 1,000. And when we divide both sides by 1,000, then my equation is gonna say 2 equals 1 plus 0.025 over 4 to the 4t. Dividing by that number is awesome. You're gonna start just about every problem that way. Perfect. Beautiful. So Scout says, maybe this looks kind of yucky. It's not really a problem for me, but it does look bad. So what is 1 plus 0.025 divided by 4? So Scout says, let's rewrite that as 1.00625 to the 4t. I just typed this in to kind of clean it up a little bit. It's still kind of not pleasant, but that's what I have now. Now what? Giovanni? Never mind. Well, it looks a little messier than some of our other ones did. But remember when we had problems like this, 2 to the x equals 7? How did we solve that? We took the logarithm of both sides, because when you take the logarithm of both sides, this guy comes out in front, right? So I'm going to take this equation and I'm going to take the logarithm of both sides. So the log of 2 equals 4t, the log of 1.00625. This comes out in front. That's why we take the logarithm. That's the beautiful thing about logarithms. We can pull that exponent off. Now this is what you're trying to get by itself. So what do you think we could do to get that by itself? Could we get rid of the 4? How would we get rid of the 4? Divide. So let's go ahead and divide. So we're gonna divide by 4. So that's gonna be gone. So now we have t log 1.00625 equal to the log of 2, log 2, close parentheses, divided by 4. So 0.0752, a whole bunch there. But that's what's on my calculator now. Are you with me? So now we have this. We're trying to get this by itself. So what do we need to do now? Divide by this guy. Won't that give me t by itself? Now, here's the good news. I'm not going to do any rounding off here because I'm going to divide by the log of 1.00625, but this number is still in my calculator. So I'm just going to hit divided by log 1.00625. What did you get? Anybody get a t value for that?
27.812.
27.8124 years. Yeah, I'm just randomly rounding. On a test or quiz, there'll be directions. I went to the 10,000s because that's what we've been doing with our calculator. Wow, you just did a real life problem. People really use that formula. It's a real formula. All right. Well, let's do the next one, and then we'll talk about our other formula. Let's do this next one. So, is everybody good with this? I'm gonna erase all this now. Okay. So I'm gonna leave my formula up there, but I'm gonna erase all this. And I'm ready to do problem number 2. So, problem number 2 says, how much will be in the account at the end of 10 years if $1,230 is invested at 3.125% compounded monthly? It is that compounded monthly that clues you in, this is the formula you're gonna use. This is compound interest. That's what that N is. How many times a year we compound. So this is your compound monthly, compound daily, compound quarterly. This is your formula. All right? So here we go. Do I know A? No, that's the question, isn't it? So A equals. Do I know P?
Yes.
P is what I start with,
1,200.
and that's 1230. Do I know my interest rate? 0.03125. Right? Do I know how many times I'm compounding a year? That's N. 12, because it says compounded monthly. So there's a 12-year and a 12-year. Remember, that N happens twice. It's the same number twice. And do I know T? 10. I always suggest that you go ahead and multiply these two together. So instead of leaving them as 12 times 10, I'm gonna go ahead and make that 120. Now, this last problem we did was messy as heck, not this one. You don't need logarithms, you don't need anything. You're just gonna type in exactly what you wrote down. You're just gonna type that straight in. And whatever you get, that's gonna be your A value. So, 1230 parentheses, 1 plus 0.03125 divided by 12, close parentheses, raised to the 120th power. this is money, so I'm gonna round off to the nearest cent. Whoops, 53. I got 1680.53. Anybody else get that?
Yep.
Boy, that is easy. That's easy. What made that last problem a nightmare is your variable was up here. And the only way to do it when your variable is up here is to use logarithms. We didn't need to do that because our variable is out here. So we just typed it in. Does anybody have a question about that problem? How the numbers, where these all came from? You got it? With that formula? Right. Then look at number 3. Number 3 is not a money problem, right? We're not talking about dollars here. We're talking about geosites, some made-up organism. How long will it take for a population of 450 geosites to double if their growth constant is 0.123? If it's not money, then you're not using that formula, so we must be using this one. Now, PERT can be used in some special money problems also, and we'll talk about that. But for now, if it's not money, it's not that. If it's not money, it's gotta be PERT. Okay, so what do all these things stand for? Well, A stands for the ending number, just like before, it's what you end up with. P is the starting number, what you start with. E is E, Euler's constant, E, the number E. R is the growth constant. In a money problem, that's the interest rate. But in the other problem, it's just whatever the growth constant is. And T is time. So pretty much everything stands for the same thing as it did in the other form. All right. Do I know A?
Yes.
What is it?
900.
900, because aren't we doubling again? Do I know P? Yep, started with 450. Remember, you're not putting anything in for E, it's just E. Do I know R? 0.123. It's already a decimal. It's not percent, it's a decimal already. And do I know T? No. That's what I'm solving for. Okay? Now, guys, I don't know if you were listening to me a minute ago. See where your variable is? See? What's that mean? You're gonna need logarithms. Now, because this problem has an E in it, I probably won't LOG, I'll probably LN, but eventually I'm gonna need to use some kind of logarithm to solve this. But not step 1. What's step 1? Divide by the 450. That is going to be step 1, almost always. Now, I'm gonna put an LN on both sides, and I want you to remember something that I told you. Giovanni?
Log E. Well, when the E's match, you can cancel it out.
Exactly. This guy right here, when an LN and an E are touching each other, that's gone. So LN2 equals 0.123T. And then if I want to know what T is, what am I going to do? What's my last step going to be? I'm going to divide by 0.123. So I just go to my calculator, ln2, close parentheses, divided by 0.123. And I got 5.64. Do I know if this is days or years? No, I'm just gonna say days. In this formula, T can be anything. In that formula, T has to be years. I don't know if it's days, could be years, could be months, I don't know. It's something, some unit of time. Everybody good with that? We're gonna do one more. One more. Okay. Read number 4. It's back to money, isn't it? Isn't number 4 about money? Is there anything different about it though?
Compounded continuously?
Compounded continuously. Now, stop. What does that mean? I know compounded quarterly means 4 times a year. Well, that would be compounded daily. Compounded continuously means every single second of every single day, every millisecond. I mean, it is continuous. Do I have an end for that? No. When you are compounding continuously, that's a PERT. So if your problem ever says compounded continuously, that's a PERT. So let's make sure we're clear on when we PERT. We use PERT if it's not money, period. If it's not money, it's PERT. If it's a money problem that says compounded continuously, then we also use PERT. If it's compounded any other way, we use the big formula. But compounded continuously means PERT. All right, so let's put stuff in. Do I know an A?
Yes.
Do I have an A? What's my A? 35,000. Do I have a P? That's my unknown. I'm gonna have to figure out what that is. Do I have an interest rate? 0.04. My growth constant is 0.04. Never put a percent into the problem. Always make it a decimal. Either formula, make it a decimal. And do I have a time?
10.
10. So I'm gonna go ahead, I always do my exponent multiplication. So that's gonna be e to the 0.4. Am I gonna use logarithms? When do I use logarithms? There's one time when I use logarithms. When the, Jacob? When the unknown is up here, when the x is up here, that's when I need logarithms. If the x is anyplace else, like, well, here I needed them because it was up there, but if it's anyplace else, I don't need logarithms. So how in the world am I gonna solve this? Square root? No. Interesting guess. No, not gonna square root. What am I trying to get by itself? I'm trying to get this guy by itself, right? So I need to get rid of this. Well, how am I going to do that? Your choices are add, subtract, multiply, and divide. How are you going to get rid of this? You're going to divide both sides by e to the 0.4. That'll cancel that out, and it'll leave you with p. So how do we type that in? 35,000 divided by second ln, second ln gives you e, look at your screen. And then your power is 0.4. You should have ended up with $23,461.20. Now, if you didn't, I want you to try again. Press the buttons that I tell you to press. Type in 35,000 divided by second ln 0.4 equals. Did you get this?
Yep. 0.4.
All right, so two big main ideas, all right, and then I'll shut up and you can get working on your homework if you want to. Two big ideas. First of all, I have two formulas. How do I know which formula to use? What are kind of my guidelines?
Money.
If it's money, it actually could be either one of these if it's money, but it's only pert in a money if it says compounded continuously. If it's any other kind of compounding, it's the big one, right? Everybody clear on that?
Yes.
What if it's not money? Then it's pert, period. No ifs, ands, or buts. If it's about a population or something like that, it's going to be pert every time. All right, that's first big idea. Second big idea. Sometimes I use logarithms. Sometimes I do log or ln. Sometimes I don't. How do I know if I need logarithms? If the variable that I'm solving for, my x, is the exponent, then I must use logarithms. If my problem has an e in it, I will use ln.